Let's take a look at some piecewise defined functions. And what we're going to want to do with these is to graph them and write them given the graph. Now, we already know about one piecewise defined function, and that is the absolute value. If you remember, the absolute value of x had two pieces to it. It could equal x if x was already positive, or it's the opposite of x if x started off as a negative number. But when we look at what we know with piecewise defined functions, we notice a few pieces. First of all, this one is defined by two functions, x and f of x. So in the first position after our braces is going to be the function for each of the pieces. Then the second part happens over here, the ifs. Right? These are the conditions under which the first part happens. So absolute value of x is only going to equal x when x is positive. As for when x is negative, it's not going to equal x. It's going to equal the opposite of x. So how do we use that information to graph f of x is equal to x minus 2 if x is less than negative 1, and x plus 3 if x is greater than or equal to negative 1? Well, first we recognize that f of x is broken up into two pieces, the x minus 2 piece and the x plus 3 piece. And each of those pieces have their own conditions. So let's take the x minus 2 case first. And what we want to do is to graph the line y equals x minus 2. Well, y equals x minus 2 has a y-intercept at negative 2 and a slope of 1. So we'll plot a few more points and graph our line. Okay. Now, this is the entire line, but we were told f of x is only going to equal this x minus 2 line if x is less than negative 1. So I find negative 1 on my x-axis, that's right here, and I'm going to look down this way. Okay. And what I'm doing is I'm cutting my yellow line because we were told that we want to keep the piece when x is less than negative 1. That's going to be this portion of our yellow line. So I need to take the rest of that and erase it. Now we can move on to the second piece of our function, the x plus 3 piece. So we're going to graph the line y equals x plus 3. Right, that has a y-intercept of 3 and a slope of positive 1. So again, plot a few more points and graph the entire line. Now we don't want to keep the entire green line. We were told that it's only going to be on this x plus 3 line if x is greater than negative 1. So again, we look when x is at negative 1, and I'm drawing that vertical line to kind of signal the boundary, so where we're going to cut that line. We want to keep the piece that is greater than or equal to negative 1. So that's going to be the right side of this line. So we grab our eraser and erase the left side. I'm also going to get rid of this dotted line. I was just using that as a boundary. Now, we are almost done. We do have to, however, identify what's happening at our endpoints. Because you notice on the yellow line, that happens when x is strictly less than negative 1. And to signal less than negative 1 but not equal to, remember we use this open circle. Then on the green line, it says that x is greater than or equal to negative 1. So on its boundary, I'll use the closed circle, the dot, to begin that portion of the line. Then we have a good graph where the top piece is going to be this line and the bottom piece will be this line. Let's try it again. This time, g of x is defined with 3 pieces. So we're going to have 3 portions on our graph. Let's take them one at a time. The first one is 2x plus 3 if x is less than negative 1. So we're going to graph this line y equals 2x plus 3. That has a y-intercept of 3 and a slope of 2. So go up 2, over 1, or down 2, back 1. Get a few points there, and then draw my line. Now our function says the g of x is going to equal this 2x plus 3 if x is less than -1. So again, on the x-axis, I find -1, and you don't have to draw this boundary, but I'm drawing it so that we can see it, that this is where we're going to cut our yellow line in half. And we want to keep the piece where the x-coordinates are less than -1. That's going to be the stuff that's to the left, this portion. So we grab the eraser and erase the stuff that we don't need. We also need to identify what's happening at the end point, and it says that our graph is going to equal this yellow line if x is less than, strictly less than, -1. So since it can't be equal to -1, we're going to use our open circle. And that's the first piece of our graph. Now for the second piece, that says that y is going to equal -x plus 2 if x is in between -1 and 2. So let's graph the line, -x plus 2, that is a y-intercept of 2, and a slope of -1, so down 1, over 1. Then we grab our straight edge and draw the entire line. Now our conditions on this portion of the graph says that g of x is going to equal -x plus 2 if x is in between -1 and 2. Now, we've already found where x is equal to -1, and we can see that x equals 2 right over here. So we're going to keep the portion of the line that's in between those two boundary points. So we take the eraser and erase the stuff that we don't need. Before we move on to the last part, we need to identify what's happening at the endpoints, and it says that x is greater than or equal to -1. So since it can equal -1, we're going to use a closed circle, the dot, on this endpoint. Right? That's saying that if x is equal to -1, we're going to be on the green line, not the yellow one. And if x is less than or equal to +2, then we're also going to be on the green line. So we're going to use our dot on this endpoint as well. And finally, we can move on to our third piece. And the third piece says that y is equal to x if x is greater than 2. So we're going to graph the line y equals x. Now this is 1x plus 0, so it has a y-intercept of 0 and a slope of 1. And so we end up with a line that looks like this. I'm going to be careful while I'm drawing my line not to mess up any other part that I've already drawn. Now, remember, for the red portion of our graph, we want to keep the piece where the x-coordinates are greater than 2. So on the x-axis, I find x is 2 right here, which means I'm going to keep the portion of the line where the x-coordinates are greater than 2. So I grab my eraser and erase these pieces that I don't need. Also going to erase those black boundary marks that I just made. Before we finish, we do have to identify what happens at the end point of this portion of the line as well. And it says that this happens when x is strictly greater than 2. So it can't equal 2 right here. So we'll use our open circle, and this would be our third portion of the line. So if you have 3 pieces in the function, you should have 3 pieces on your graph as well. So what about if we're going to go the other way? What if you have a graph and I want you to come up with the function? The few things that you should notice about this function is that, first of all, we have 3 pieces. There's this line that goes down and to the left. There's this short segment in the middle. And then lastly, there's this horizontal line that goes off to the right. That means that when we're defining our function, which we'll call h of x, we need to leave room for 3 separate functions. The first function we'll deal with is the one that's on the left, the one in yellow. And if I look at this, I need to think about it as a line. This is a straight line, so lines have the form y equals mx plus b. When I'm looking at this one in particular, I can see that the y-intercept is at 3. And my slope, I can go from one point to another and just count that my rise is 2 and my run is 1. So that means my slope is going to be 2, and my equation is y equals 2x plus 3. So the first piece of my function is going to be y equals 2x plus 3. The other thing you have to identify is the condition. It's going to be this line, not for the entirety of the function, but only for certain x values. And all we have to do is look at that endpoint, and it happens down here when x is at positive 1. So we're taking all the values that are smaller than positive 1, so x is less than 1. And you have to check if it can equal 1 as well. And what we notice is that at the end of our line, we have this open circle, which means that x is strictly less than 1, but not equal to it. The next piece in the function is that short little line segment in green. And once again, that is a line, so we are going to need something in the form y equals mx plus b. I can identify the slope pretty easily because from one point to the other, I go down 1 and over 1. So that means our slope is going to be negative 1. And to identify what the y-intercept is, I'm just going to extend that line back towards the y-axis, and I see that it crosses our y-axis at 2, which means the y-intercept is going to be at 2. And now we have an equation for the green portion of the line. It is negative x plus 2. And before we finish this portion, we have to identify what happens at the endpoint. And we see that this very short segment is only going from 1 to 2. So that means that x is going to be in between 1 and 2. Looking at the endpoints, both of them are closed circles, these dots. That means that it can equal 1 and 2 on this portion of the line. Finally, the last piece of the function is the horizontal line in red. As we look at this line, it has a slope. Again, we'll need y equals mx plus b, but its slope is from one point to the next. We don't go up or down any, and we run 1. So its slope is going to be 0 over 1, or 0. If we were to extend that line back to the left, we see it has a y-intercept of 3. And we simplify this down to say that y is going to equal 3. So the third portion of our function is just 3. And when does that happen? Well, looking from the endpoint, x is going to have to be greater than 2. And because that's an open circle, we are not going to have or equal to. It's just going to be x is strictly greater than 2. And that's how you would take a piecewise graph and write the function for it. Write each piece, the equation for each piece, as well as the conditions for each of those pieces as well.